So today we're going to be starting a new series looking at math for real-life applications. And here's our first example, merging on a highway. And I should probably write that down. Merging on a highway. Now this is going to be different depending on what sort of highway you're going on. And this particular highway, the speed limit is 110 kilometers per hour. But you may live in an area where it's 100 kilometers per hour or something different, or maybe it's miles per hour. It really depends on where you live, but we're going to be using the good old metric system for this one. So we're driving in car A here. Use a different color for that. We're driving in car A over here, and we can accelerate at 2 meters per second squared. We have a relatively low acceleration, but very comfortable as well. And we're trying to merge onto this highway, and we have this next car here traveling 110 kilometers per hour. And what we want to know is how much distance do we need to leave for this merge, and we'll denote that as variable x. And that's what we're solving for here. How much distance between these two vehicles is safe, so that if car B is traveling at 110, it doesn't have to change its velocity in order to avoid a collision with car A. So maybe it's a one-lane highway or the other lane's blocked and it can't move over. We don't want car B to have to change its velocity. So we have some people who try to merge at 0 kilometers per hour. And we're going to see why that's a bad idea when we look at this 80 kilometer per hour and 100 kilometer per hour merging speed with our acceleration at 2 meters per second squared. So first, let's make some assumptions here. We'll say that this is constant, which is not actually going to be true for most vehicles because you have shifting gears, you have friction at different speeds. It's not going to be a constant acceleration, but we're going to assume it to be constant for the purposes of this exercise. Car B is at a constant velocity. Let's convert all of these into meters per second. So basically, to convert from kilometers per hour to meters per second, you need to divide by 3.6. And that's just a simple units conversion. So we have 30.56 approximately. At 0 kilometers per hour, it's 0, obviously. 22.22. 27.78 meters per second. So this will make things a lot easier, and since we have a constant acceleration, we can derive the equations of motion. So for constant acceleration, we know that acceleration A is equal to the differential of velocity with respect to time. So if we want to figure out what velocity is, we get dv equals a dt, and we will integrate this from 1 to 2. We will get v2 minus v1 equals this acceleration, which is constant, so we'll have a times t2 minus t1, or a delta t. If we take t1 as being 0, the initial time is 0, then we just get, we'll say t2 equals just t. We can just basically say that v2 minus v1 equals at. Simple enough. And with our initial velocity v1, makes it even easier. So we know that what we want v2 to be. And let's do this in red to make it stand out. We want v2 to be the highway speed, 30.56 meters per second. We know what v1 is. That's what we're traveling already. 0 kilometers per hour, 0 meters per second. We have 22.22 meters per second, and we have 27.78 meters per second. Our acceleration, 2 meters per second squared. And our time is the variable that we want to solve. Interestingly enough, if we increase our acceleration, our time will decrease. So let's basically split this into 3 parts, and I will add another page there. I'm using a new program called Xournal, Xournal. Has a few interesting features. I just wanted to see how it works. So rearrange the equation to get t equals v2 minus v1 divided by a. And what we get here for this one, t equals 30.56 over 2 equals 15.28 seconds. Here, t equals 30.56 minus 22.22 all over 2, which is 4.17 seconds. And here, 1.39 seconds. So this gives us the amount of time that we have for each of these, the amount of time that's required for each of these. We now have the times required, but we want to know what distance is required, this distance x, so that if this guy is traveling 110, he's going to be here, then we don't want them to collide, basically. And since his velocity is constant, we can basically just apply this acceleration equation. So, we know our definition of velocity. Velocity equals displacement with respect to time. We have our equation for velocity up here. Now, we've chosen to put it into this differential form, but we'll say that v2 is just our variable v. So, for our velocity, v equals, we have v1 plus at. And now we're integrating this with respect to time to get displacement. So we have the x integral from 1 to 2 equals integral from 1 to 2 of v1, which is a constant, plus at. So we have x2 minus x1. We'll be saying x1 is 0 equals v1, our initial velocity, times t2 minus t1. t1 again is 0 plus a t2 squared minus t1 squared. And again, t1 is 0. Sorry, I forgot to divide this by 2. So this should be over 2. We'll say x2 equals x. This equals our v1 t plus 1 over 2 a t squared, which many of you may recognize as being the constant acceleration equation for displacement. It's just a basic integration here. So what do we have for the 3 different conditions? We have 0, 22.22 at 27.78 meters per second. We also have t equals 15.28 seconds. We have t equals 4.17 seconds. We have t equals, I forget, 1.39 seconds. So now we can find x equals 233.5 meters. We have, for this one, x equals 110.0 meters, and finally we have x equals 40.5 meters. And we see a trend here. As our merging speed increases, the distance required to merge decreases. Now, we did this using constant acceleration equations. You could use relative motion to get the exact same result by saying that the vehicle B is fixed and vehicle A is traveling backwards initially at the highway speed and is trying to achieve zero velocity such that it does not collide. Let's just graph this out. Say 1, 2. This is just how I graph to try and make it to scale. Sorry if this confuses anyone. So about 233, that'd be in here. That's if you were traveling at 0. So this would be V1. And this would be merge distance. If you're traveling at 80 kilometers per hour, and I realize, just looking at the recorder here, my pointer is not in the same place as where I am writing. So if that has caused any confusion, I sincerely apologize, because I only just noticed that. So sorry. This one's at about 110. So you just have to basically go where the writing is, not where the cursor is. Sorry about that. The next one, we had done 100 kilometers per hour, so that'd be around here. 100, and it was 40.5. So pretty close to here. And at 110, theoretically, there would be no merge distance required. So, let's kind of see how that decreases there. And you can see, going at a slower velocity when you merge is a very bad idea. So basically, let's make our analogy complete here. I know this is pre-completed. We have vehicle B traveling at 110, right? If we did this the opposite way and had vehicle A traveling this way at 110 kilometers per hour such that its velocity right here is 0, then we would get the exact same answer, which kind of allows us to know that this is the correct solution. Vehicle B is traveling at 110, vehicle A is traveling at 110 when vehicle B is right there, basically. Now, let's just put a disclaimer on this. You don't want to have 0 distance between you and the car behind you when you merge. You want to leave a little bit of distance, maybe 100 feet, in addition to what you have. And you want to use common sense. You want to be safe. If there's absolutely no gap, then you might not have any choice. I'm not going to tell you how to drive, so I don't take any responsibility for how you drive or what you take away from this. But basically the moral is, you don't want to be stopped here, because then, look at this, you have 0.2 kilometers to merge. 0.2 the next car has to be 0.2 kilometers down the road. That's a pretty long distance compared to if you were traveling maybe 100 and they only have to be 40 meters down the road. And this assumes that we don't want them to have to change lanes or alter their speed. So, that's basically the moral of the story. I'm Spider Pilot, that's all for today. And I hope that you found this at least a little enlightening. Thank you. Now you know how to merge onto a highway, but you still don't know how to pay your taxes. I'm Spider Pilot, and that's all for today.